Greetings, geometry students. Today we are going to be continuing our discussion of how Euclid's three basic structures of the point, the line, and the plane can interact with each other to make some additional structures. And we're going to be looking at segments, angles, bisecting, and midpoints. Please copy down the title, and then let's take a look at the objective and the essential questions. Okay, our objective for today is student will be able to discover the topic of congruence and apply it to midpoints and bisectors. Congruent is going to be a word that we are going to use probably no less than about 10,000 times this year, so we're going to need to get a good understanding of the word congruent, and then we will see its very first application with the idea of midpoints and bisectors. Now, the language objective, how I'm going to get this information into your head, is you are going to demonstrate for me mastery of the required vocabulary and concepts by responding to questions involving provided diagrams and hypothetical scenarios. Those will be the questions that I pose to you on the assignment. The essential question, the last thing you should ask yourself before the lesson is finished and put out of your mind temporarily, would be, do I understand the new vocabulary and naming systems, and can I apply those topics to provided diagrams? Once you finish your worksheet in class, you ask yourself that question. If you are good to go, then you probably don't have to worry about this lesson a whole lot more except for studying it a little bit. If you are still fuzzy on some things, you will need to come in and get some help. As always, press pause anytime you need more time, and then hit play when you're ready to move on. So let's take a look. Okay, right off the bat, new term, congruent. Okay, so that goes on the left side of your paper, and then here comes a definition. If line segments have the same length, we say that they are congruent. We use a symbol, a little shorthand notation, to show that two things are congruent. Now the symbol, as you can see there, just looks like an equal sign with a little squiggle over the top of it. Some of you may know that squiggle as the name tilde. Okay, but it goes over the top of the equal sign. And when you use that, that is pronounced is congruent to. Okay, so let's say we're looking at, in this case, a couple of line segments. We have line segment AB and we have line segment CD. We are provided with information about the lengths of both of those line segments, obviously a 7 and another 7. We would be able to make the statement that line segment AB is congruent to line segment CD. And basically, the term congruent simply means equal measurement. So we are establishing that the lengths are the same, the measurements are equal. Okay, so that is how it's pronounced. Line segment AB is congruent to line segment CD. You can see how this symbolic notation greatly helps with the amount of material that we have to write down. It would have taken, what is that, a 9-word sentence, something like that, to write that out. Okay, the little shorthand notation with the bars over the top and the congruent symbol, much shorter to write it down with symbolic notation. Okay. Another new definition we have there are tick marks. Okay, if line segments are congruent in a diagram, tick marks may be used. And I'll show you what tick marks look like. Okay, in this case, we have the same two line segments, line segment AB and line segment CD. This time we do not particularly know what the measurements are, but you see we have these little hash marks that are across each of the line segments. When you have a matching number of those little slash marks, those are called tick marks, and tick marks mean that whatever these lengths are, they are the same length. So once again, we would say that line segment AB is congruent to line segment CD. Okay, angles. Okay, we're going to spend a little bit of time discussing angles here in the coming days, and we're going to look at how they are formed. So we're going to start off with parts of angles. Now, we've already talked about rays. Rays are a special kind of Euclid's lines, and an angle is composed of two rays with a common end point. That common endpoint is called the vertex of the angle. Now we've actually already seen an example of this, and we'll come back to that here in just a second. Okay, there is an example that would go along with the definition that we just said, composed of two rays with a common endpoint, which is called the vertex of the angle. Okay, so in this case, point B is going to be referred to as the vertex, and there are obviously the two rays that are moving away from the vertex. We'll find out later those are called the legs of the angle. Okay, but can you think about where we've seen an example of an angle already? We talked about opposite rays the other day. They started off at a common endpoint and went straight away from each other. That was actually a type of angle that we'll be getting to shortly. Okay, now the naming system for angles is a little bit tricky at times, so we better make sure we get a good understanding of it. Angles have names that we can refer to when needed. Just like every other thing in geometry, we will have a way to name angles. Now sometimes, not very often, but sometimes angles will have a small number inside of them near the vertex that we can refer to that angle by. Okay, so for example, maybe we see something like this. We have two rays coming from a common endpoint, and they put a little number inside near the vertex of the angle. They are giving us a name for this angle. Okay, we could call this angle 1. There is a symbolic notation for the word angle, and it looks a little bit like a less than sign with a little curved arc through it. Okay, but that is pronounced angle 1. Now some people get confused about this and they go, wait a minute, I thought when you put a number inside of the angle near the vertex that you were telling us how many degrees that angle would measure. Well, if you'll notice near that little 1 right there, do you see a degree marker? No, you don't have that little floating circle to the right of the 1. So this is not an amount of degrees, this is a name. Okay, moving on. Now, assuming they do not give us that little number down inside of the angle for us to call it conveniently, like angle 1 we did just a minute ago, more times than not, we are stuck using the 3-point system in order to name an angle. Okay, so it's going to take, just like with planes, it took us 3 points to name a plane. It's going to also take us 3 points to name an angle. And there is a trick to naming angles. You absolutely must list the vertex of the angle as the second point out of the 3 that you are using to name it. Okay, so the vertex gets listed just like it is in the diagram. It gets listed in the middle of the rays. So the angle from the last page, which you should have right there in front of you on your paper, would be either angle ABC or angle CBA. Okay, but notice on either one of those possible names, B is listed second. B is the vertex, so it is listed in the middle of the 3 points when we name our angles. Now, just like with line segments, we have a way to show in a diagram that angles are going to have the same measurement. With line segments, we called that a tick mark. It was a little straight line that we marked the center of the line with. And anywhere we saw matching numbers of tick marks, that meant that we had matching measurements. We had congruency. Okay, well, there's not a little line like a tick mark that we put in an angle, but we do put a small arc near the vertex of the angle. Okay, so if we look at two angles, in this case we have angle DEF and we have angle XYZ. In each of those cases, please notice I listed the vertex second. And inside of those angles, you can see we have matching little arcs inside of there. Okay, just like with the tick mark, when you find those matching angle congruency marks, that means however big these angles are, it is the same for both angles. Then you would be able to make a statement like this: angle DEF is congruent to angle XYZ. Now on the angles, just a little side note on the 3-point naming system, it does not matter which order you have them in. So angle DEF could have just as easily been called angle FED. Angle XYZ could have just as easily been called angle ZYX, as long as the vertex is listed second and then its points on its rays are listed on either side of it, should be good. Okay, now to the topic of midpoints and bisectors. These are going to come at you all together because in a lot of ways these guys are synonyms of each other. Not exactly synonyms, but it's kind of like when one of them applies, the other one applies as well. Okay, so you're going to get several statements here that are going to sound very similar because they do all have very much the same meaning. Here's a new term, midpoint. You should know what midpoint means already, but let's write it down anyway. Midpoint is something is a midpoint if it divides a line segment exactly in half. Now you will never run into a midpoint on a ray or a line because those guys go on infinitely and it's impossible to divide infinity in half. Okay, but you do catch them on line segments. Now here's, like I said, not a synonym, but you will see these words are closely related. Once you have something that is cut in half, we say it is bisected. So there's another new term for you, bisected. Of course, the prefix bi means two, and sected means to cut something up. Okay, so it is cut in two equal pieces. That is bisected. Okay, so there's a little diagram, and you can see we have a large line segment JL, and we have a point K, which lives on line segment JL. On either side of point K, we have line segment JK on the left, line segment KL on the right, and one tick mark shows up on each of those two smaller line segments. So the communication to us is that line segment JK and line segment KL are congruent. So statements that could be made about that situation: point K is the midpoint of line segment JL. And that can be said since line segment JK and line segment KL are congruent. Okay, another way that that can be stated is that the length from J to K is equal to the length from K to L. Remember when we put back-to-back points like you're looking at right there, without any type of a bar over the top of them, we are stating that those two lengths are the same. The length from J to K equals the length from K to L. Yet another way of stating this is that line segment JL has been bisected by point K. All three of these statements say the same thing, but as many of you are probably already aware, in the English language there are a lot of different ways of stating the exact same sentence, and we do run into that a good bit in the geometric language as well. Okay, different ways of reorganizing the information, a different word from time to time, and you can still accomplish the same thing. So it's important to know all of the vocabulary, because if we can state it three different ways, that means they can ask the question three different ways and expect us to know what to do. So we have to know all of the language in order to understand any question that they might come up with. Okay. One more way, even further than that, points J and L are equidistant. There's a new term for you, from point K. And equidistant means exactly like it sounds like it means. The prefix equa means equal, and distant is, of course, referring to the distances. Equidistant means equal distance. J and L are equidistant from point K. Again, a lot of different ways of stating it. That means a lot of different ways we need to understand, a lot of different vocabulary we need to know. Okay, that is it. What we're going to be doing in class is you're going to start running into the little bit of math that goes along with these for the very first time. So I want to give you a crash review on solving equations. So please copy this one last screen down. There are 5 steps to solving an equation, and you may have seen the poster that is in the room. If you have not, you may want to spend a little bit of time studying it. Let's write them down now. The 5 steps. First step you want to do when you are solving an equation is you need to deal with any parentheses or binding operations symbols of inclusion that are going on in the problem. So that'd be parentheses, brackets, braces, any of that kind of stuff. That needs to be dealt with first. Step number 2, you need to combine like terms. If you are unfamiliar with what like terms means, you probably need to come in and start seeing me for tutorials immediately so we can figure out when you are allowed to add two things together or subtract two things together. You need to know what like terms are. The step 3 right there, and I deliberately left a little space, so please leave a little space in your notes there as well. Your variable, if you have variables on both sides of the equal sign, you need to pick one direction for them to go. So my step 3, I just say variable goes one way. So either all your variables go left or all your variables go right. Whichever direction you sent your variables in step 3, you need to send everything else the opposite direction. So if in step 3 all your variables went left, that means everything that is not a variable is going right in step 4. And on step 5, this is what I call the 1 and 1, and that refers to your variable. And the first one means you need to have a 1 for a coefficient for that variable. That's the number in front of the variable. And the second one is the exponent. That's the little floaty number that comes behind your variable. Okay, so that's your 5 steps. Parentheses, combine like terms, variable goes one direction, everything else goes the other direction, and get your 1 and 1. Now I divided these into 2 groups for one simple reason. Okay, things that are going on in steps 1 and 2, nothing is going across the equal sign. We are staying, what is on the left stays on the left, what is on the right stays on the right, and in order to do that, you are going to follow normal math rules, meaning if the problem says to add, you're going to add. If it says to subtract, you're going to subtract. If it says multiply, you're going to multiply, and so on. However, steps 3, 4, and 5, all of this deals with sending information from one side of the equal sign to the other side of the equal sign, and in order to do that, you must always do the opposite of whatever is already being done. If something is being added and you want to move it to the other side of the equal sign, you do the opposite of addition, which is subtraction. If it's being multiplied, the opposite of multiplication is division. Okay, so anytime you jump over the equal sign, you always do the opposite of whatever's already being done. Now, some people like cutesy little ways of remembering things, kind of like your order of operations. Please excuse my dear Aunt Sally, or PEMDAS, however it was that you were taught it. Okay, chances are you've got that stuck in your head for doing parentheses and exponents first, multiplication and division second, addition and subtraction third. So if you like cutesy little ways of remembering stuff, and this is on my poster in the room, I have a little acronym, a little saying, and my saying is parents' complaints vary for everyone. Okay, everybody's got parents, and everybody's parents are always complaining about whatever their problems are, or their problems are with you, or whatever. Okay, but everybody's parents have a different set of complaints. Okay, if you can remember this, then you can basically remember the first several letters of each step. Okay, first word in the acronym, parents. The first step of the 5 steps is parentheses. You notice they both start with P-A-R, parents in parentheses, parents in parentheses. Second word, complaints. Okay, first few letters of this step 2, combine, complaints combined. You got the C-O-M in common. Step 3, okay, I think you get the hint here, variables vary, parents' complaints vary, okay, variables. And the 4 doesn't really have anything in there, but every deals with everything else, everything else. And then 1 on the end deals with the 1 and 1. Parents' complaints vary for everyone. If you can remember that, then maybe that can help to remind you, parentheses, combine like terms, variable goes one way, everything else the other way, and you're 1 and 1. If you can get through these 5 steps without messing anything up, then chances are you can probably solve an equation. If you know for a fact that you are not an equation solver, trust me, we are not going to spend time in geometry class teaching you the algebra that you are supposed to already know. So if you know that you cannot solve for x, you need to be coming in for tutorials immediately and begin getting that taken care of. The math of geometry is algebra. You're expected to already know it. Okay, that's the end of the lesson. We will take these 5 steps and we will see if we can apply them to some geometric situations with midpoints and bisectors and things like that in class on Friday. I appreciate you taking time to get your notes taken care of. I'll see you in class.